So this is where we left off in the last video. Sorry, I'm running out of space. So here we separated these using our exponent rules. So now this is just, we said c is a constant, so e to the c is just a constant. So I'm actually going to write that. I can use anything I want. I'm going to call it a p, just for kicks. And so I've got y equals pe to the kt. Does this look like anything we've ever seen before? Yes. So if you remember from Algebra 2, you always call that PERT, except we used an R here for exponential growth, or continuous exponential growth. So say we had, let's see, so we want $10,000 after 6 years at 5% interest. Okay, compounded continuously. So it's compounded continuously. We would know that we're using the equation a equals p e to the RT, which looks pretty much identical to that one. So if we plug that in, say I need $10,000, I don't know how much I'm starting with, 5% interest over 6 years. We could actually solve for p. So I'm going to grab a calculator. Oops, sorry. And see what is e to the 0.05 times 6. And I get 1.34895. 1.348. Sorry, 985. We'll say 9. So if I divide 10,000 by that, I end up with almost $7,400. So we need $7,400 to be able to have $10,000 after 6 years. So that's just algebra, but it's kind of cool that we use calculus to get to the equation. So that's just kind of a reminder of where that comes from. Okay, the last thing we talked about is very similar to that. Is basically just still finding out what is the equation we're looking for if we're given a differential equation. So say I have y times y prime minus 2 e to the x equals 0. And we want to say, well, what is my original equation? Okay, because I know this is basically my derivative. So this is dy over dx. So I've got y dy over dx minus 2e dx. Okay, so my goal is I'm going to take the antiderivative, but I want to get all my y's on one side, all my x's on the other. So let's see if I move that over. Let's try to use a little bit of algebra here. Let's see what we can do. I can add that over. There we go. I'm getting close. So all I need to do is multiply by this dx. So I'd have y dy equals 2e to the x dx. That was a weird dx, sorry. Weird dx. Okay, so now I'm just going to integrate both sides and take the antiderivative. So the antiderivative of this one would be y squared over 2. And then my antiderivative of this one is just going to be 2e to the x. And then we just add a plus c to one side or the other, doesn't matter which one. And then we solve for y. Now, since I've got that y squared, I could just leave my answer in y squared. So say I multiply by 2, still plus c. So take a constant, multiply by 2 is still just a constant. So it's not really changing anything. So we could leave it like this, or we could we could take the square root and say it's plus or minus the square root of 4e to the x plus c. So either way, this one actually looks a little prettier, but it doesn't matter. We could do it either way. So let's do one more of those. So say I have, we'll say dr over ds equals e to the r minus 2s. And we want to solve this. So we want to get our r's on one side, our s's on the other. So we need to separate this. Now, remember our rule a minute ago, if we were adding, we could separate using addition. So here, we can separate these using division. Right? Or, if you wanted to, we could have still just left it as a multiple, so it's negative 2s. Either way, it really doesn't matter. So what I'm going to do is get my r's on one side, so I'm going to divide by e to the r. So I've got dr over e to the r equals e to the negative 2s ds. So I'm going to go ahead and write this one as e to the negative r dr, because it's easier to work with. So if I integrate both sides, now we know when we take the antiderivative of e to the x, it's just e to the x. Now with this negative, that means we need to put a negative in front of it. So we've got negative e to the r equals here, let's come over here and say let u equal negative 2s. So my du would be negative 2 ds. I don't have a negative 2, so I'm going to move that down front. So I would have negative 1/2 e to the u du. So this is just e to the u. So I've got negative e to the r, negative 1/2. E, we said u was negative 2s plus c. And we could leave it like that. Or, I mean, yeah, we could multiply by negative. Let's see if we could clean this up a little bit. 2s, still negative 2s plus c. But I would probably just leave it like that. So that's not too bad. So that's all of chapter 6. It's mainly slope fields and then being able to take our antiderivatives. All right, thank you.